now the conclusion about polar coordinates here. So we'll start off by recapping some things we know to be true about circles. So first up, the circle equation, at least the real basic version, r squared is going to be x squared plus y squared. You know, something we talked about in the last lesson, the way you get x is r cosine theta. Y is pretty similar to that. It's going to be r sine theta. And the tangent of theta, if we think about any kind of triangle that happens on the unit circle with the xy distance, tangent of theta is going to be y over x. Something that's going to be really important as you go through this homework, those identities that you did throughout chapter 5, they're going to come up quite a bit throughout this lesson through here. So just kind of be aware of that. I gave you a page number for you to go back and reference some of those things. I have to brush up on a few of those identities as you go. Your first example says to convert to polar form. I'm just giving you y equals 5, so a function we should be pretty familiar with. That's going to be a horizontal line through 5. Looks like that. All right, before I just throw you in here and say, hey, let's get this to polar coordinates, or a polar function, let's look at what that would be. So let's go back to the calculator, go to mode, make sure you are in polar mode now. And let's go to y equals and see what that's going to look like. So now we have r equals. Instead of y equals, we have r equals. So that's how we want to solve this thing. We want to solve for the radius, r. So with that in mind, we're solving for r. Let's think about how we can make this happen. Well, let's think about what we could do with y, substitution we could do for y that contains an r. All right, you should be immediately thinking about how y equals r sine theta. So let's make that substitution. That's all I did, just a substitution. Y is r sine theta. So let's just do that. We want r by itself. So I'm going to take 5 and divide by sine theta. Now, the nice answer you should give on your paper is 5 cosecant theta. That's really what I'm looking for my final answer here. Calculator doesn't have a cosecant button, so you really I'll have to here so you can see what to put in the calculator. Now we know what this should look like, so let's go to our calculator. Let's do 5 divided by sine theta. Now that variable button, when I hit that now, it's going to put a theta in. Polar coordinates is the third symbol, that's a theta. And it should be a horizontal line through 5. If it is, we got it, so it looks pretty good. That's a good way to check to make sure it looks like the function you expected it to be. The next example, I picked something else that we should be pretty familiar with at this point. So that's x squared plus y squared equals 25. That's a circle with a radius of 5. That should be pretty easy to see if we did this right when we get done. So once again, you should be thinking about ways to turn x into something with r, ways to turn y into something with r. So x squared is going to become r cosine theta, and that is squared. Y is going to become r sine theta, also squared, and it's just going to equal 25. I just substituted. I didn't change anything, really. I didn't do anything to the equation to both sides. Just substituted. So that's going to be r squared cosine squared plus r squared sine squared equals 25. Factor r squared out of both of these, so r squared times cosine squared plus sine squared equals 25. Now cosine squared plus sine squared is 1. So let's just make that substitution. R squared times 1 equals 25. No point really including the 1, so r squared equals 25. And finally, r equals 5. Technically plus or minus, it really won't matter here, but usually we just take the principal root and say r equals 5. Again, you could graph r equals negative 5, and it would just graph the circle backwards, but it'd be a circle. So that's fine too if you want to do that. So that's our final result. R equals 5, way simpler than our function mode, less pieces going on. And let's just confirm. So let's go back here, and let's just say 5. Should be a circle with a radius of 5. Looks kind of elliptical because the screen is a rectangle and it's trying to squeeze it all in anyway, but yeah, that's a circle with a radius of 5. So I want to pose a question to you. What does r equals 0 look like on a graph? And if you want to put it in the calculator, you can, but it's not really going to show up unless you have the color version, then it might give you something. All right, but if r equals 0, then how far are we going from the origin? Well, we're not going anywhere. So that would just be a dot. So a point at 0, 0 if you're in rectangular coordinates. Just the origin, basically, just a point at the origin. As with everything in math, now that we've done it one way, let's go the opposite direction. Let's make sure we can go forwards and backwards. So convert these polar equations into rectangular form. All right, well, first up, you've got r equals 6 cosine theta. Now, just a heads up, be ready to hit some dead ends. It's going to happen. It's part of the process. Stick to those 4 identities I put up there on the first screen. Those would be really helpful. Those trig identities from back in chapter 5, those things are going to come up throughout your homework. So just kind of brush up on those as you need to. But again, you're going to hit dead ends. It's part of the process. You'll get used to some things to look out for. You'll start to notice some patterns, and then by the quiz and test, you'll be more efficient. So that's where we're heading. We're trying to get more efficient at what to do. But these are puzzles, so it's okay if you hit some dead ends. All right, we've got r equals 6 cosine theta. Well, I know I want to get x and y back in here. I want to get rid of these r's. So my instinct here is to square both sides, because I'm thinking, all right, r squared, that would be x squared plus y squared. But then when I square this, I have cosine squared, and I don't really know where to go with that. So that would be an example of a dead end. So I need to get another way here where I can end up with just x's and y's. Now, seeing that cosine makes me think about, all right, well, what can we do with cosine to turn back into x? Well, x is r cosine theta. So if I could make that r cosine theta, that would be awesome. And to make that happen, let's try multiplying this by r. And if we do it on the other side as well, that's going to be convenient, because that's going to give me r squared. So r squared is 6r cosine theta. And let's convert these down. So r squared is x squared plus y squared. And r cosine theta is x, so that's 6x. I'm trying to make this a normal function, so I want to solve for y. All right, so y squared would be 6x minus x squared. Okay. And I just need to take a square root, solve for y. So square root of both sides. And that should do it. Y equals plus or minus the square root 6x minus x squared. This example is kind of tricky. It reminds me of the equivalent of a x equals vertical line in function mode. Because if I go to the calculator, everything's given to me in r equals form. There's no theta equals option. Just like with the function mode, there is no x equals option. That's not a function. So this is an example of something that's not really truly a function in polar coordinates, but it does show up in function mode. It's possible. So let's think about how we can get around that. Same way you can graph a vertical line, even though the calculator can't handle it, doesn't know what to do, but you can make it happen. You know how to graph a vertical line. It's not technically a function, but it can be made, it can be drawn. So think of it that way. All right, 4 pi over 3. Well, if I start here on unit circle, let's go put me down this way. That's 4 pi over 3. Now, when you do a vertical line, let's say x is 5. So here's my coordinate plane. X is a vertical line of 5. Well, x is 5, but y could be anything. And that's what creates all those possible points. No matter what the y value is, you've got x coordinate of 5. Same deal here. No matter what the radius is, radius could be all sorts of decimal numbers. Anything you could ever imagine would be on that ray right there. What if the radius was negative? Now it could be back here, and that extends it to a full-on line. So it's anything that's on that line right there. Well, we can easily do functions that graph lines. That should be very doable. The start to this one's a little tricky. I'm going to start with something we know to be true, and that's the tangent of an angle equals y over x. But I need that to solve for theta, so let's take this and solve for theta. So arctangent of y over x is theta. So by substitution, this angle, 4 pi over 3, must equal arctangent of y over x. And if I take the tangent of both sides, that undoes arctangent. So tangent 4 pi over 3 would have to equal y over x. All right, well, tangent 4 pi over 3, third quadrant, so it's positive. Reference angle is pi over 3. So that is square root of 3. However you want to reconcile that, it is the square root of 3. Multiply both, to wrap it up, multiply both sides by x. So x square root of 3 is your equation. To test this, I'm going to go back to function mode, put it in the calculator, and see if it looks like it falls on that line. So mode, back to function. All right, so now I'm back here. I'm going to say x square root of 3 and see if it looks like that line. Looking pretty good. I feel pretty confident about that. So that'll do it. That shows that that is the correct line. All right, one last thing. Just remember, you're going to hit dead ends. If you could make it through this whole homework assignment with never hitting a dead end, then that's amazing. You're probably the first student I've ever encountered that could handle that. So just remember, go back to your trig identities back in chapter 5. Be familiar with those. Be familiar with those first 4 identities I put up here in the presentation. And just it's like puzzles. Just keep at them. Just keep trying things that are possible, and eventually you'll get through these. Just keep trying stuff.